because historically they've been very egotistic about like, oh, we're the best, we're the brightest, we're the number one. No one's going to beat us, right? So they've been saying that for a while, and now Gemini's beat them, Anthropic is beating them, um, Kling is beating them on video, DeepSeek is there's like half a dozen people beating them on various things. So
Yeah.
clearly they're not the best, and they're not the brightest.
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lin. Practical AI is brought to you by Pocket AI. Pocket AI is a visualization tool that allows you to prune your models without any loss in accuracy. Visualizing your model weights is like a brain surgeon being able to find individual neurons and removing them without harm to the brain. Similarly, Pocket AI allows you to analyze and prune the weights in your model. Using Pocket AI, we have proven we can select the right backbone model, get that model to actually work, make that model more stable, increase a model's accuracy, decrease the size of a model by up to 60%, and put smaller models into production for half the cost. Finally, you can be done with endless brute force training and new model trials. Pocket AI allows you to perform brain surgery on your existing models, making them not only smaller, but better. Peter, today we wanted to hit the Google/Nvidia TPU versus GPU conversation because it's kind of relevant the last week and this week. But before we do that, we kind of wanted to get into a fail. You could look at it as a fail from OpenAI's perspective, or a win for kind of the open source DeepSeek community. It looks like their new version their new model that they're coming out with next year is going to do a lot of things differently.
Yeah, yeah. So there's a video recently from OpenAI where they talked about some of the new research that they've been doing, and one of them is they give the prompt a hint, and then they try to see how does the model reason. Right. So the system with the hint and without the hint. Without the hint, they prompted and got an answer. With the hint, it gave the answer that was in the hint. So like the answer was C, but then it came up with some bogus reasoning for how it got to C that was completely it just made up. It was hallucinated. Right. And so this is kind of they're borrowing ideas from other researchers from other places like open source where they're instead of telling the models think in this way with chain of thought, they just let it think. So that's kind of dangerous because if you don't know how it's thinking, then you can't validate whether or not that's valid. And you also don't know if what it told you was the way it arrived at the solution is actually what it did.
So this form of thinking, I can't remember, like open space thinking or something
Latent
like that.
space, yeah.
Yeah. Kind of was launched or kind of hit the wire when DeepSeek launched their paper. And you and I kind of said, we talked about this back, that it would make sense for the rest of the big wigs to get on board with what DeepSeek's doing,
Yeah.
because they would probably accelerate their success, right?
Yeah.
Whether it's AGI or just, making revenue, whatever it is, they're probably going to be more successful if they can do what DeepSeek is doing. So is it that significant that OpenAI is basically on board now with DeepSeek's methods? And what does it mean? Is this a Hail Mary? Is this
Well, I mean, I don't know, but just from an engineering perspective, if there's a good idea, you're dumb if you don't look at it. And you're really dumb if you don't look at it and spend time to understand it and play with it and see where you can take it. Because if you don't do that, then you're just an idiot at that point. You're just living in a bubble of like, I'm the greatest in the world and there's nothing anyone else can teach me.
yeah.
And then you're doomed to fail. So it's good that they've because historically they've been very egotistic about like, oh, we're the best, we're the brightest, we're the number one. No one's gonna beat us, right? So they've been saying that for a while. And now Gemini's beat them, Anthropic is beating them. Um, Kling is beating them on video. DeepSeek is there's like half a dozen people beating them on various things. So
Yeah.
clearly they're not the best and they're not the brightest. There's lots of smart people around the world.
Okay. Well, and do you think that others are going to use this forbidden method of?
Oh yeah, I'm sure people are exploring this in research and other places. Yeah.
Okay. Good. And we didn't get too much into the forbidden method, but it's basically if I'll dumb it down. If you don't know the chain of thought and it's not kind of spelled out for you and you can look at it, you're basically just outsourcing or pushing the thinking into a black box that you can't see,
Yeah.
which could result in it making up stuff,
Oh
figuring
yeah.
out a way
Yeah.
around it, something.
Yeah. The real danger is, I mean, everyone's trying to get to a point where you can interpret the models, right? So this is that term interpretability, which means can you understand what the model weights are doing? Can you predictably validate that it's producing things in a reliable way? If it's a black box, you can't. There's just no way.
Yeah.
And therefore, if you're deploying this product to the public, what guarantees can you give a customer, right? So it says, hey, you say your app can tell me the right medical advice. Well, how do you prove it? If it's a black box, you can't.
Yeah, and this makes the box a little blacker, although the results seem better.
Right. And so there's a danger. Yeah.
Yeah. All right, well, let's pivot over to the awesome TPU GPU conversation, and this is Google hardware. Essentially, they are not alone in sort of chipping away a little bit at Nvidia and their sort of dominance in
Yeah.
the processing space, but they're doing it with a different thing. We've talked about TPUs before, but give us a refresher on TPUs versus GPUs and what Oracle is doing.
So TPUs were started a while ago by Google when they started using models. They realized, oh, actually, we need something better to run this more efficiently because using GPUs wasn't efficient enough. And so they started TPUs many years ago. Now they're on version 4 or 5 now. Actually, they're on 5. So now they've gotten to the point where now their stack is actually more efficient than Nvidia's because they've been using it for probably a decade now. And they have built out in their data centers what they call TPU pods, where I mean they started to build the first 2 versions of TPU didn't use water cooling. And then version 3 was water cooled and it was made into a pod. So they got a bunch of TPUs together, linked them all up with fiber, and then they could do more. And so now they're on version 5. And it's more efficient. And I think, a lot of people mentioned early on that chances are Google has an advantage that OpenAI doesn't because they have the data centers already. They have the TPUs, they have the hardware expertise, and they have the software, and they have DeepSeek. Not a DeepSeek, they have DeepMind division in the UK.
Okay. And just stepping back, how does a TPU process differently than a GPU?
So TPU is really a bunch of small processors that are designed specifically for machine learning workloads, whereas GPUs are designed to do things like graphics and machine learning stuff. Although the newest version, Broadwell, that actually they stripped out a lot of the graphics stuff to focus more on just machine learning. So they've been moving towards a design that is more stripped down and more optimized for machine learning and less for graphics.
And when we talk about training versus inference, is that relevant here, or like sometimes the
Yeah.
chips are kind of and the data centers are kind of geared towards just training or just inference? Is that can they do both at Google on these TPUs?
So the new version does. It's actually going as far as back as version 2. When they trained AlphaGo, they used TPUs. But it's taken them years to get to the point where now it's more general purpose than before. I guess before they had to write custom code that understood the TPU hardware architecture in order to optimize it. And so really they only used it for their own internal projects at DeepMind and at Google Brain.
So if you were a um, stockholder of Nvidia, are you selling?
Well, good question. I don't know.
Well, the fact that you're not saying no,
Yeah.
and is probably more significant as than if you just said yes. Because for what 5 years now, Nvidia has just been on this tear,
Oh yeah,
and
I mean, they've been sold. They've been booked for at least 6 to 12 months ahead.
where do you think you and I've talked a little bit in the past about one of their biggest advantages is not just the hardware, it's the software that oversits on
Right.
top of
The
that,
CUDA
right?
stack.
So CUDA with all their libraries for sequencing and all the various things you can do,
Yeah.
is that going to give them enough of an edge to outcompete some of the hardware players now?
No one really knows. So the thing is, so Google, AWS, Microsoft, Apple, they don't need to reproduce everything. They just need to produce something that they can use that lowers the cost. If they can do that, they'll win. So it doesn't matter if their stack can't do, let's say, like, geoencoding of like map data. It doesn't matter if it can't do gene sequencing because that's not their workload. Their workload is running models. If they can
Okay.
run models faster, cheaper, more efficiently, and with lower cost, gotta win.
So Google may or sorry, Nvidia may always win in the 20% of stuff that is 80% more expensive to run or whatever,
Yeah.
whether it's folding proteins or whatever. But in the 80% of stuff that is common, that's where they're going to be at risk, right?
Oh yeah.
Because that's if
And
you're
then
going to
with
build a competitor,
inference,
that's where you do it.
inference is going to be more and more important as things scale out and more people use models.
And where do the GPUs, sorry, where do the CPUs fit into the inference space?
CPUs really don't really do much when it comes to inference.
Okay.
Yeah.
And these new TPUs can run inference as well.
Yeah, they do both.
Yeah. Good. Well, it's going to be fun to see what happens here in this like 8-horse race. And well, as an outsider, it seems like between all of these big firms, Nvidia, Meta, Google, even Apple, we'll throw them in there. Whenever anyone gets out ahead, it appears like the rest of them want to take that person down.
Yeah, but that's how the market works.
But what's interesting about that is that the get out ahead lasts for about 3 weeks.
Yeah, no, it's you have to keep running. You have to be paranoid, right? If you're number one, you got to be paranoid because is gunning for you.
Right. And then meanwhile, in the behemoth that is looming out there is anything that China is doing and possibly some other nation states, right?
Yeah, I mean, right now there's Google, there's Meta, there's Microsoft, there's Apple, there's Cerebras, there's Grok, there's Huawei, um, and then there's a few more small players that are trying to, but they probably won't make it.
And then maybe the nation state of Saudi Arabia or something like that could
Oh
happen.
yeah, yep,
That's about it. It's like if it's
yeah,
not a
just a few.
nation, yeah, these are the teams.
Yeah, they're trying to, yeah,
Yeah.
yep.
Good. Well, this is a good discussion. We'll pick this up again. Keep an eye on Google and Nvidia and this GPU TPU horse race. You can follow us on Spotify. We'd be happy to meet you there if you prefer just to listen. Also, remember to listen to us in 2x speed because Peter and I talk slowly. And then we will catch you next time with another topic. If you have any questions, let us know. Take care, everybody.